Welcome to another educational video by Meston Educational Services. In this particular video, we are going to look at complex numbers. In this section, we're going to look at polar and Cartesian form of complex numbers. And in Cartesian form, we normally write in terms of x and y coordinates, or x, y, z if we're talking of 3 dimensions. And in the polar form, we write in terms of r and theta, where x is r cos theta and y is r sin theta. Now, to get the complex number on the calculator, all we need to do is to click on the pi key twice and we will get the complex numbers in the calculator page here. And the first thing that I wanted to look at is the settings. So if we go to number 5 and document settings, you will see there is an option to change the real or complex format. So I could go to rectangular, which is Cartesian, and I could go to polar. However, for the time being, I'm going to just leave it in the real number format because I'll actually use the conversion within the calculator. So let's go and add a complex number. So let's say my first complex number that I'm creating is 3. Actually I'll go to root 3 and then plus, and let's say 2, and to get the complex number I click it twice, and there we have. Let's go and store this as Z. So I have now got my complex number. Now if I go into menu and number 2, and then number 9 is complex number tools. Now I've got various complex number tools over there. So I could convert it to polar form, I can get the magnitude, I could convert to rectangular. So all the complex number tools are over here. So let's go and first use the complex conjugate command, and if I do Z, it gives me the complex conjugate. Let's try another command over here. So number 2 for numbers, then number 9 for complex numbers, and this time let's go and convert to polar form, so which is number 6. Now this clearly tells me that the angle is -pi on 6 and the magnitude is 4. So if I want to go and check the magnitude being 4, once again we follow the same steps, and this time if I go to number 5, magnitude of Z, and it should give me 5. So this is how we use the complex number tools. Now if I was to go and actually use this particular answer, so I'll just copy that, so Control C. Now if I convert it to Cartesian, it should give me that form there. So menu 2 and number 9, and this time convert to rectangular, number 7, and you can see it gives us the desired form. Let's go and just try something else out. So if I go into document and then I go here, and this time I'm going to actually change the angle to degrees, and let's see what happens now. If I take this complex number, which is my last answer, so if I do control and my last answer, and this time I want to convert it to the polar form, so number 2, number 9, and then convert to polar, number 6, and this time I've got in degrees. So it says the magnitude is 4 and the angle is -30 degrees, so it's going in the clockwise direction. So it depends on the angle settings as well. So now we'll go and try this question on the CAS. We have a complex number in the polar form, so we will and the other thing is we are actually finding the inverse of its conjugate in the rectangular form. So to do this question, we'll go into the complex number tools. So once again number 9, and we're actually going to first find the conjugate, and our complex number is 2, and I'm actually going to use the other form. So if I go in here, and you will see I've got all the symbols, and if I scroll up I have the symbol for angle, and the angle that we have is -pi on 3. So that's the angle we have. So what I need to do is, because I'm finding the conjugate, and now I need to go and do power -1, and you will see it gives me the number in the rectangular format. So it found the conjugate and then it's inverse. So that's the answer that we are expecting. Let's look at another question. Here I have a complex number where the real part is 1/4 and the imaginary part is -√3/4, and we are determining z to the power of 3. And I can simply put that into the calculator as it is to the power of 3, and I get my answer as -1/8. However, if I convert it to the polar form as I've done over here, and then I use De Moivre's theorem over here, you'll see I still end up with the same answer. Let's look at another question over here. We have got a complex equation, z to the power of 4 minus 6z cubed plus 18z squared plus m times z plus 65 equal to 0, and one of the roots is positive root 5, the imaginary part. We need to determine the other roots, and also we need to determine the value of m. Now to do this on the calculator, we'll go to menu, and this time we'll go to number 3, and then if I click option C, you will see I've got some more complex number tools. So the first one is complex solve. So we're going to use number 1, which is complex solve, and I've actually got the equation there, which I'm going to simply paste, and we are actually solving this for m. And if you note over there, I've put m times z, so do not put mz. So now if I solve for m, it gives me the equation. Now if I go and do the last answer that I obtained, and now if I go and substitute z equals, which was √5, and I need to tab out, and then I put the imaginary number. Now it should give me the value of m, and it says m is -30. Now we need to find the other roots, so we still need to use C solve. So I'll go back and number 3, and then C, and number 1 C solve. And now if I go and paste the equation back, I have to put m as -30, that I'm doing now, and this time we are solving for z, and it should give me all the roots. So I've got all the roots over here, so these two are conjugate of each other, and these two are conjugate of each other as well. So that's how I would determine these on the calculator. Now I have got a user-defined function as well, and I'll just demonstrate the user-defined function. So you will notice over here I've called the function all complex. So all that's where the complex number will go in, and I've got actually 3 sets of matrices, and each one of them have got 3 rows. So that's just the text part, what will be displayed. Now this is actually giving the approximate form of the answer, and this is going to give the exact form. So the first one is actually giving me the magnitude, the angle, and then the angle in degrees. So all 3 are there. So because I've got 3 matrices, so first augment will put 2 matrices together, and then the next augment will put the third matrix along. So if you see, that's a better view. So you'll see there are 2 augment commands. That's matrix 1, that's matrix 2, and matrix 3. So the best thing would be to pause the video when you define these on your calculators, or alternatively the best thing would be to download this from the file that will have the questions. You will see over here I've just used it with a particular matrix, so that gives me the magnitude in decimal form, exact form, in radians in the decimal form, exact form, and angle in degrees, and that's in the exact form. So that's another one that I've done. So it's pretty helpful.